Okay, this is part 2. So again, let's take a look. What we're trying to solve for is what mu is going to give us the best equation to find out what is going to give us our friction. Because we have to play with different mu's to find out which mu is going to give us the right acceleration for the net force and the net acceleration in the x direction. So going back to our data, this was all the data that we played with before, and I have all of these forces. So friction force for 0.01 up through 0.09. Again, this is arbitrary. Mu can be anywhere from 0 to 1. Some substances have mu's that are greater, but not ones that we're going to see in this course. Again, on page 90 of your textbook, you'll find a table of common mu's. So this is a second page that I created out of the data that we calculated already. And I'm referencing everything by whole number. I've got acceleration measured. Again, this is what we measured with wing length, TA minus TB over TA times TB times TAB. And this is our g sine theta, again, without friction, so therefore it's not a good model. And as we can see here, we were off by 74%, so this was not a good model. So what we're going to do now is play with the different forces and mu, values of mu, that might get us closer to what we want. I've done every column here or every set in a different set of colors, just to make it easier to see. You should not print this out. What you should do is share it with me in Google Docs instead. And in your lab, just write up that data table is shared in Google Docs. How do you make your own copy? Do File, Make a Copy, and then call this your name and block, so C or E block, or E, and OK. And then it's now going to be your copy of it. And then you're going to go up here and hit share, and then you're going to share it with me. Obviously, I wouldn't already be here because it's yours, and you would share it with forcemassacceleration@gmail.com. and tell me that I can edit it, then save and share. All right, so let's go back here. All right, and other things I'm going to need is I'm going to need the mass of the car and plate again to be able to make a conversion using Newton's second law to find the acceleration. And this is what we see here. So this was our friction force, mu, which is 0.01 times Fn from our other page. And all I did was copy and paste out of here. Now, the thing is when you copy and paste a formula, it's still going to be looking for the reference points from before. So you want to make sure that when you paste something, you're actually pasting special. And what you're going to want to choose is paste values. Because when you paste values, that's going to take the number that it found in this sheet and then transfer it into this sheet. So just make sure you're doing edit, paste special, and then paste values only. Now I don't need the force of friction. I need the acceleration of the force of friction. And to find that, what I'm going to do is just rearrange Newton's second law. So acceleration is equal to force of friction divided by mass. That's why I have this here, so we can see this. And this is just a simple this column J divided by this column E, and I get an acceleration. Again, negative because it's going up the plane. Then to find the true force, action force going down the plane, I'm going to take my g sine theta, and this is going to be minus my mu cosine theta. And I have this here, and we can already see it's getting closer. So before we were off by 74%. With a 0.01 mu, we're closer. It's only 60% off. Yay! I do it again for 0.2. Again, not so good. 0.3. Oh, getting closer, 30%. 0.4. Ooh, getting closer still, only 14% off. Do it for 0.05. Oh, wow, now we're getting really close. We're getting under 5% for some of those. And then 0.6. Oh, getting a little bit higher again. 0.7, getting higher still. 0.8, oh, higher still. 0.9, going in the other direction now. And that's where I stopped. So what you're going to make a determination here is looking at all the percent differences and trying to figure out which mu makes the best model. And with that, then answer the questions. Now let's say you wanted to make a graph. How would you do it? Let's say I wanted to do a graph of whole number versus acceleration. What I would want to do is I'm not going to use every single data piece in here. I'm going to have to be selective because if I do every single data piece, it's going to make a really ugly graph. So this is where you're going to want to do some summing with each data piece. So I'm going to actually grab all of this data and I'm going to just work with 0.01. You may not want to work with 0.01, that's okay. I'm going to hit Control C and copy, or File, Edit, Copy, and I'm going to make a new page and then Edit, Paste Special, and then I'm going to do Values Only. And so that's putting the information in. Oh wow, I got more than I wanted. Oh, that's right, because I had some stuff hidden. So I am going to rehide some of this. And all hiding does is it helps you then see things a little bit bigger, a little bit differently, and a little bit clearer. Now you can see this is giving you tons of significant figures, and not significant figures we're going to use. If you remember using our CPO timer, it only gives us 4 significant figures. So I'm going to go Format, and then Number, Custom Decimals, and I'm going to say 4. And percent difference, Format, Number, I'm going to go down to percent. I'm going to keep 4 sig figs there. And then do the same thing here. Format, Number, Custom Decimals, 4 sig figs there. And percent difference here is going to be Format, Number, and then down to 4 sig figs. Okay. Again, you can play with that. All right, so let's take a look at what we have. We have our whole number and our percent difference. So let's say I wanted to get an average. I'm going to go here, highlight, and I'm going to insert one row above, and I'm going to type in sum, and sum is just a function that says to add. And I'm just going to highlight what I want to add, close the parentheses, and then I'm going to divide by 15 data points. Divide by 15, and I can get an average here. So one average, I'll just call that 1A, is going to be an A measured. So that's our average. And now I can take this formula, copy it, and I can just paste it into here. And I don't need to do, well, I could do it for that if I wanted to, but I don't want to, so I'm going to undo it. Don't need to know it for the car. Do the force of friction's all same value. I don't need to know it for that. Don't need to know it for that. And now A calc mu minus friction. Nope, that's all the same. but I'm going to put it in there anyways because I want that. And here, and again, format, number, and then decimal percent off. All right, so we're saying the average percent difference for all the holes is 59% here. And just because this is going to be a data point I'm going to use in a graph that I'm going to generate, I'm just going to color the, take this and highlight it in a different color so I can see it later. So, oh, let's say blue. All right, and so then I'm going to do the same thing with 2, go between 2 and 3. Right click, insert one row above, and then I'm going to do the same thing. Equal sign, sum, open parenthesis, highlight what I want to sum, divide by the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Excellent. Now, we have different number of data points for each one because depending on how many pieces of data each group took. So I'm going to need that again for here. V, Control V, Control V, Control V. All right, and again, format, number, percent. Let's see. All right, again, I'm going to color this one because I'm going to use that as my average for hole number 2. And 2A. So I'm going to continue to do this for each of the holes, 3, 4, 5, 6, all the way up through 19. Now I can make an easy hand graph of hole value versus acceleration real, hole value versus acceleration calculated. So I would have a graph with hole number on my X and A measured and A calculated on my Y and see how far close those are. I'd make sure that these were, again, I would say in my title that these were averages. I would also make sure that while I was graphing this that I used one symbol for A measured, one symbol for A calculated, and show a key on my graph. You only have to do this for the mu you think is best. So look through all the data, figure out what mu you think is best. Do not do this for all the mu's. You only have to do it averages for the mu you think is best. If you need any help, let me know.